Hi, I'm Dee, here at the Kennedy Space Center Visitor Complex in the Mars Base 1 Botany Lab. One of the big challenges of growing plants in space is the behavior of water in microgravity. On Earth, if you pour water out, gravity pulls it down and plants use their root system to draw it back up to nourish the plant. If you try that in space, though, the water simply clings to the roots and the plant suffocates. Basically, it drowns. Because in microgravity, water is always going to form a sphere. Maybe you've already learned in science class about two of the properties of water, cohesion and adhesion. Cohesion means the water sticks to itself. That's why it forms the sphere. Adhesion means that water is pretty sticky and it'll stick to just about anything else as well, which is why we have to come up with ways to feed our plants in space, taking those properties of water into consideration. Now on Earth, water still has those same properties, but it's a little bit harder to observe because gravity is always pulling the water down. Still, you may be able to see the cohesion of water doing some very simple activities at home. One of them is simply to take a cup and fill that cup to where it's almost overflowing. And if you look at the top of the cup, you'll notice that the water actually forms a little curve. That's known as cohesion or surface tension. And the meniscus of the water is where those water molecules bond even more tightly to hold that water in place. Now there's some interesting things that you can do to show this other than simply filling a cup to overflowing. And one of them is what we call the Great Penny Challenge. I'm going to demonstrate this for you. All you need is water, some kind of an eyedropper. I have a pipette, but you can use any dropper as long as it will release the water one drop at a time, and a penny. If you don't have pennies, any coin will do. I just use the penny because I have one. We're going to show you a close-up of how this works, but first let me just demonstrate. What I'm going to do, and this does require a steady hand, is I'm going to drop one drop of water onto that penny. And I'm going to keep doing this until it overflows. Your challenge is to find out how many drops of water you can get on the surface of a penny. So that's drop number one, and if you look closely, you can see that the drop is curved on the top. It's not quite a sphere, but it is a hemisphere. I'm going to add drop number 2, 3, 4, 5, 6. How many drops do you think I'm going to be able to get on this penny? 7, 8, 9, 10, 11, 12, 13, count with me, 14, 15, 16, 17, 18, 19, 20. Oh, and the number 20 was the one that broke it down. Did you see how round that got? Okay, now we're gonna pull. So I only got 20 drops of water on the penny. Let's see if you can get more. There are some variations you can do on this to make it a true science experiment. For example, can you get more drops of water on the front of the penny or the back, heads or tails? Does it make a difference how high you hold the dropper? Does it make a difference what kind of dropper you use or the water temperature? There are lots of different variables that you can change to make this into a great experiment. Post your results in the comments so that we can see how well you did. Can you beat my 20? Here's an activity you can do at home to amaze your friends and family. All you need is a cup, some water, and a paper clip. Now, because my fingers are not very nimble, I'm going to use these tweezers. You don't have to. It just helps me to place the paper clip carefully on the water. Now, a paper clip is made of metal, so obviously if I put it into water, it's going to sink, right? But if you do this carefully enough, you can make the paper clip float. Now, it's not a magic paper clip. It's just that the water tension on the surface is holding it in place. If I break that tension, down goes the paper clip. Again, this is just a fun little activity that you can use with water properties and surface tension. How many others can you think of? Share the results in the comments below, along with any questions that you might have. This is Dee from Kennedy Space Center Visitor Complex, reminding you to keep looking up.